find. There we go.
Okay, very good. All right, so we'll just, try to jump in if there's anything pressing popping up in the chats. So we're watching like the Mattermost and the Zoom chat.
Mhm.
So if there's anything, I'll just let you know. And if there's anything in the room here, I can let you know. So
Very good. And
Okay.
is my screen, is the text viewable from that room?
It's a little small.
All right.
I mean, yeah, it's a little small.
So how about that? Like, hopefully that's viewable.
I think it's
And,
okay.
all right.
Yeah, I think that's okay.
All right. And how many people are there? Is there a way that you can point a camera at the audience? Because right now all I see is.
Oh, yeah, that's a
videos.
tough sell. I'm not sure how to work that camera.
Fair enough.
Yeah, there should be like a remote somewhere. We have like what is it, like 10 people in this room. About thought it might be over here. No.
It's zooming, it's just not.
Not rotating.
Yeah, it's zooming. I'm trying to figure out how to rotate it. Sorry, not super expert with this. I can stand up on the chair and physically turn it.
Don't, if it's too difficult, don't worry about it. I'll just do this blind and hopefully the audience, if the audience, wants to, interject, I heartily encourage the audience to interject since I can't see confused looks on their faces.
They're all smiling and awake. So.
Oh, that's fantastic. And they're all really happy to be there.
Yeah.
Yeah. Okay. I don't think we can. We'll just interrupt you when we can.
Perfect.
Okay.
Maybe I should also have the Mattermost up just in case. What is the preferred way for people to ask questions in this remote format? Should I be checking Mattermost or chat?
So that's what I was saying. So we're monitoring, we have people watching Mattermost and the Zoom chat. I mean, because I think it's a bit difficult for you because like the other speakers were splitting screens between the tutorial and like a terminal. So it's a bit much unless you have another. So if you have another screen where you are, you could put like the Zoom chat open and or Mattermost, but we'll let you know. I think if there's something in Mattermost, it'll just be easier to maybe stop you as we go. If anything pops up.
In that case, I'm just gonna go and we'll see what happens. All right, everybody. So I'm here to talk today about how you put together reconstruction algorithms inside EIC Recon and what the different pieces are and where they live and why they do what they do. You're going to start by motivating this with a physics example. Actually, before then, we're going to take a step back. So we have this whole simulation, reconstruction, analysis pipeline. And generally, we start with event generation. We run that through some kind of simulation, which would generally be JON4. We eventually digitize our simulated data, which we're not doing right now. But either we feed the simulated data or the digitized data directly into the reconstruction, which produces all of our reconstructed results, which then get used by analysis. And generally, people are a lot more familiar with what goes on for them to do their analysis, as opposed to what happens inside reconstruction. And I'm hoping to sort of peel back the curtain, so to speak, and just really show people what's going on. And like, I understand that a lot of people are not going to be writing reconstruction algorithms themselves. And so we sort of have different categories of users of EIC Recon. Like many users simply need the data files that are produced from EIC Recon. Many other people are simply modifying individual parameters that EIC Recon uses and rerunning it and then analyzing the results. And then there's another class of users who are going to be saying, okay, well, we're going to take an algorithm that we've already developed in the context of one detector, for instance, and apply that same algorithm in the context of a different detector. And all you have to do there is sort of rewire the algorithm to, use data and parameters in a different context. And EIC Recon makes that very easy, and I will show you exactly how to do all this. And then finally, you might want to add new algorithms, and that is what this example is. So our motivating example is that we want to do a simple electron identification, and we're going to be using an EP cut. I am not a physicist. I do not know or particularly care about the pros and cons of the EP cut, but there are plenty of people there who do. So just use it as a motivating example. And what our electron ID algorithm is going to be doing is we're going to be taking some data that has already been produced inside EIC Recon in the form of reconstructed tracks, calorimeter clusters, and then the matching between the tracks and the clusters. And we're not going to worry about how we obtain that matching. So that matching could be done just by looking at the truth information, or it could be done by doing something sophisticated. But at the end of the day, that doesn't matter to us because we have this decoupling of how things get done. So we're just assume we're going to be given some tracks, some clusters, and some matching. And then we're going to be producing these reconstructed particles. All right. Let's begin. The first thing that we're going to need to do is to create a factory. And you might have seen, wait a second, this tutorial is titled Algorithms. What is going on here? What is an algorithm and what is a factory? Aren't they kind of the same thing? And in computer science and in other physics collaborations, maybe they are more or less the same thing. But in EIC Recon, we have a very crisp distinction between these things. And I would like to share that with you right now. So algorithms perform one calculation that we need, and they do so in an extremely generic way. And so an algorithm in principle can be reused by different frameworks. And factories, by point of comparison, are precisely what lift the algorithms into the context of the JANA framework. So the algorithm is a really lightweight piece of code that you can test, that you can do all kinds of things with, and it doesn't pull in the rest of EIC Recon at all. It just does its thing. But then you have the factory, which goes and says, this is how we obtain all the inputs. These are the outputs that need to be published. This is how we name all the outputs so they can find each other. This is how we make
Nathan?
Yes.
Can you just increase your size again of the screen?
Okay. How is that?
That's better. Yeah, that's even better.
There's like a whole essay here, so I don't know how much of this you're going to be reading, but this is, important information that I'm going to have in front of me. All right. So the basic idea is that all of this plumbing and bookkeeping, all that is handled by the framework, and the algorithm itself is something that is blissfully independent of that. And all the algorithm knows is that you receive these input collections, output collections, parameters, and services, and then you call it a day. All right. Now, in order to understand factories, we want to take a step back. So EIC Recon is sort of divided into plugins. And plugins are a JANA feature. The whole point of the plugins is that you have different pieces that you may or may not want to pull in. You may or may not want to compile them on a particular system. You really want this decoupling The critical idea is that the different pieces of EIC Recon communicate almost exclusively through the data model. So, you read these inputs, you produce these outputs, all of these live in our data model, which is called EDM for EIC. And all of the components of EIC Recon are in principle completely separate binaries. And this is really valuable because it means that if you need to pull in something really heavyweight that other people don't necessarily want to pull in, then you can do so and you can put it in its own plugin, and nobody else is forced to compile with your god-awful dependencies. Now, it's possible to put your analyses in these plugins as well, and that's what Jana 2 is designed to do, and that's what GlueX does. That is not really what we're doing in EIC Recon. So in the context of EIC Recon, you mainly have plugins just for the dependencies and the services we already have, and for individual detectors. And so we're not going to be doing analysis in plugins until people decide that we do. Now, where do we put our new factories? So we have this organizational scheme inside EIC Recon. We have this source detectors. And then under that, we have plugins for individual detectors. Now, if you have algorithms, we have this blanket source algorithms, and factories, we have this blanket source factories. So that's pretty simple. And once again, if you're doing something that is really specific to one detector, you probably want to put your factory under source detectors. Otherwise, put the factory under source factories. And then the other important thing to understand about the plugins is that you have this init plugin method. I do not have an example here. Maybe I can pull one up in a second. But the idea is that the init plugin method is where all of the components that the plugin uses are provided to the plugin. And this lives in a .cc file that has the same name as the plugin. And that is the place where you really interact with the plugin itself. All right, one more thing. So we know we need to create a factory, and the factory is the natural starting point for all of this. But it turns out we have a whole bunch of different base classes of factories. The good news is there's only one base class you should be using, and its name is JOmniFactory. And this base class actually lives in the EIC Recon repository for now, so you can take a look at it if you want. If you're interested, there's a whole history lesson about the 4 different iterations of factories that we have, but I'm going to skip that in the interest of time. And I guess the important reason why this is here is as you're going through the EIC Recon code base, occasionally you might come across like these J-chain multi-factories. And you can think of these as being slightly weaker Omni factories that we're working on getting rid of. Okay, so now this brings us to the JOmniFactory interface. And the idea behind the JOmniFactory interface is that we're really declaring what we need up front. And the framework is retrieving everything you need when you need it. And so there's a bunch of fairly complex bookkeeping that has to happen. But the end result is that you are able to sort of dynamically rewire and reconfigure these factories and reuse them in interesting contexts that you wouldn't be able to otherwise. If you've ever worked with Jana before, or if you've seen some earlier tutorials from like a year or two ago, then you would have learned a lot about these different callbacks that we have. We still have these callbacks, but they're much simpler now. We've moved the functionality out of the callbacks and into what I'm calling registered members. That's a pattern we'll see in a moment. But there's really 3 sort of callbacks that exist in the OmniFactory world: configure, change, run, and process. So configure is run once when the factory is instantiated, and configure runs immediately after Jana has injected parameters and services. And so if you need to do extra stuff like configuring your algorithm or passing in services or whatever, then that is the place to do it. But that is really, this is called once when the factory is started up. This might be a good point to mention that factories in Jana, there are many instances of them. In fact, there should be as many instances of each factory as there are threads. And if you want good load balancing, maybe you want 2, possibly even 4 times as many factories as threads. So that means that, there will be a lot of these factories floating around. And we'll talk about why that is in a bit. But just be aware that when you say, hey, we're going to initialize this something, it won't just be initialized once, it'll be initialized once, possibly twice, possibly 4 times for every thread. Change run is a callback that gets called when the run number changes. And this is important for when you have things that are keyed off of calibration. Sorry, you have calibration data, or you have resources and things that are keyed off of the run number. We're not really using a run number in EIC Recon right now, so you don't really need to do anything inside change run. It's just sort of there. But we will be using it more in the future. Thanks, Holly. Yes, that is a good point to make. Process. So process is really the important one. Process gets called for every event. But again, the factories are sort of thread local. So process will be called for every event on some factory. You can't guarantee that every factory will see every event, because it won't. If you need to process the entire event stream, we have something called an event processor for that purpose. Anyway, so for process, process is the callback when you have an event. And when you have an event, you also have inputs and you have outputs. And Jana will have already prefetched your inputs before process gets called. And then it will already produce those outputs once your process finishes. And then there's one other little piece of complexity. So JOmni factory is using the curiously recurring template pattern. The curiously recurring template pattern is this pattern right here, where you have a template that takes the child class as an argument to the template. And the reason you do that is so that you can avoid a little bit of pointer indirection and make the code a little bit faster. But you don't really have to worry about it. You literally just have to type this and it'll work. So this is a skeleton for a Omni factory. As you can see, Omni factory lives here under extensions Jana Omni factory, and then we just inherit from it. And we'll talk about these later, but basically this is where you declare these registered members. So we're saying, hey, we have an input, it's of type MC particle. We are giving it this member name so that we can access it. And it just cheerfully lives right here. But the important thing is that when we're registering it with this, this parameter, and what that does is that means that we have a handle to the pod.io input, but so does Jana. And this is because we don't have the world's best introspection in C++, and we make up for it by manually registering our input with the parent class. And parameters follow the exact same pattern, and we'll talk about that later. But here are the callbacks, and then here is the famous process method. And then for now, we just have a little bit of logging saying, hey, we've called this process method. And now we come to the inputs and outputs. So we have several different flavors of inputs. We have pod.io inputs, we have regular inputs, and we have variational pod.io inputs. We also have just plain old inputs, but we don't use those in EIC Recon, so just don't worry about them. The reason we don't use the plain inputs is because the plain inputs assume that your domain model is just like a vector of pointers. And we use pod.io for our data model, and that has much more complex semantics. So a vector of pointers isn't what's going on there. So we pass in actual pod.io collection objects, no vector of pointers. Variational pod.io inputs are fun because that's where you're saying, I don't just need one pod.io collection, I need a bunch of different pod.io collections. And these pod.io collections, they're all of the same type, but we don't know how many there are. And we find out how many there are by providing a list of collection names, and however many are in that list is the number we provide. All right. So we're just going to declare that we need a collection of MC particles. Notice that we're not declaring the name of the collection we need. So there might be 5 or 6 different collections of MC particles floating around our system that mean different things, and you need to use the correct one. And I'll explain to you later how you or where you provide the collection name, but we don't really provide it here. Now you can, if you look at this example up here, this example is a little bit old, and we are in fact providing a collection name, which happens to just be MC particles, as another argument to this pod.io input constructor. But you don't have to do that. For the sake of simplicity, just don't. We're actually going to put that information somewhere else in the general case. All right, so you've declared this M particles in, this is your input, and now you would like to get some output. And then it literally just looks like that. So you can just call, you do need the parentheses. So the reason for that is because M particles in is it's a wrapper. I thought about also adding a dereference operator because I slightly prefer the dereference syntax to the function call syntax. But yeah, so M particles in is not actually a pod.io collection. It wraps a pod.io collection as a constant MC particles collection pointer. And you have to pull it out of this. So the M particles in actually has type pod.io input parameterized with the collection type, and it has a base class of just input base, I think. And so there's a very, yes, do you have a question?
Yes, so M particles in is also a function or method of the class of Java factory. How can be a method? It's some template construction of the method.
So M particles in is an object.
But there are figures which indicates they are either a function or method.
So we can call the object like as though it were a function or method because we're overloading this operator. So you can, if you want to be really fancy, you can think of it as being like a closure or a runnable in Java. If you ever interact in that universe, but it's an object that you can call like a function, and it will return the pod.io collection that is contained inside of it.
Thanks.
Is everyone at peace with that, or you need a little bit of time to digest that? Because it's a very good point. Like it's a little bit weird, and it's a level of indirection. All right, so we have this particles in that we're extracting, and then there's something similar. And if you thought that was weird, this is going to be a little bit weirder because now you can say M particles out equals, a pod.io collection. And you might say, well, wait a second, how can I assign to a function call? That shouldn't be right, but it is. And that's because that, this thing which looks like a function call is really returning a reference to a pod.io collection pointer that you can set. So when you call execute, it returns a pod.io collection, and then mParticles out returns a reference to a pointer, and then you're actually setting this reference to this pointer.
So it is basically functional programming.
You can think of it like that. I don't think functional programmers would particularly like this either, honestly, but it's a way of exposing the reference, and it's a syntax for that. All right, so another way you can think of it, honestly, is as being like another smart pointer. So instead of using a dereference operator, we're just using the function call operator. But it really is like a smart pointer in that it's an object that behaves like the thing that it contains. All right, so that is all that I want to share with you right now. I have a very small exercise. So we're going to be just pretty much copying this code skeleton into our EIC recon and seeing if we can just set it up and give it some log output and give it some input collections. And we don't even need to compile it right now. We'll do that in the next step, but we just want to.
Nathan, can I interrupt you again?
Yes.
So just for everybody here, so I didn't know if you wanted to guide them to getting this, because we haven't done anything with EIC recon today.
Oh, wow.
So people probably don't have it yet. So
Oh.
like they have EIC shell and things like this, but maybe if you can, I don't know, bring up a terminal to get people to this point, it would probably help.
I will definitely do that. Thank you for mentioning that. I was hoping that there'd be at least one EIC recon thing happening before me, but that is quite all right. All right, so we're going to take a step back. We're just going to exit out of all of this. All right, so we're going to launch our EIC shell. Hopefully everybody has done that. And then we're just going to do git clone https /github.com/EIC/EIC recon. I'm going to need to do this in another directory actually, because I already have one over here. Is everybody following along? Silence means yes. So now you have an EIC recon, which lives in the EIC shell. And we're going to compile it. Actually, just for the sake of, make this a bit bigger. Hopefully everyone can read that. We're going to create a build directory. We're going to go into the build directory. I'm just going to cancel that so that you can still see this.
Prefix path for make install.
I didn't catch that. One more time.
Do you need the prefix path for make install? I always install it to someplace other than the default place to install it. I think, yeah, let's just do that just to be safe. So we're just going to put it in here /install. And that way we don't have it potentially clobbering your weird little file system. Yeah, because I don't ever do it the other way, and I'm not sure if it's gonna, mess something up. I don't quite know how your CVMFS is set up. Let's just verify that it's installing to the right place.
Just FYI, typically by default, there's like a prefix directory in your home directory, or usually in the home. Somewhere there's a prefix directory, and that gets put in the LD library path anyway. So if you install into that, then that gets preferably picked up without destroying whatever is in the container.
Makes sense. Yeah, I think I know what you're talking about. Actually, if you know where that is, we can find it and just use that.
Just find in the home directory the directory name prefix. I hope that exists by default. I'm using yet another build environment, the drich def one, where prefix lives in a different spot.
I don't think we have prefix. I know we have local. I think local is. I'm just gonna do it the way that I always do it, and I know works, so that I don't have to
Yep,
debug.
that sounds great.
something
Yep.
that I don't understand. I'm guessing people didn't see the thing that was on the screen before it went away. So just so that people can see, what I did was I set a CMake prefix path and I put it in my build directory, and then I added a install directory sort of in the build directory. And yeah, there's nothing special about that. That's just a place where it can live.
So since we have you here, can you scroll down a little bit, because there's always the yellow CMake warnings. Can you make those go away in some future iteration?
What a great question. I agree, it would be nice. It might be a bug in DD for HEP, honestly, but I know that one looks like it's a bug in the DD for HEP config. Environment variable.
Oh yeah, I see.
Yeah, but I wouldn't be surprised if we have weirdly conflicting CL HEPs or boosts that some people other than me had to work really hard to find a configuration that worked. Because those
And no
always
no
run
priority on
into-
that, but I wanted to point you in that direction if you have spare cycles and want to dive into CMake.
Maybe you should file an issue. All right, so has everybody got the thing to build? Or if nothing else, at least you're not complaining about it. So I'm just going to keep going. So we're back under build. We're actually going to need to create the install directory. You might wonder, why am I creating a build, an install directory under the build directory? It's mainly just so that I can, clean everything by deleting build in one fell swoop, and I know that install also goes away. That's just me being paranoid because of, past experiences with CMake. So we have a CMake that I think finished. So now we can say nice, stop it. Nice make -J20 install. Everybody got that? If you're running on a laptop that doesn't have 20 cores, then don't do -J20, do however many cores your laptop has. Actual machine that's remote like I am, then by all means use all the cores you've got. All right. I don't think that actually built it. Why didn't that build it?
Because you're not in the tutorial directory, I think. I can't really see well the blue, but looking at the installation feedback there, it goes to EIC Recon, not tutorial EIC Recon.
You're right. Thank you. This is the beauty of having many eyes on what you're doing. Okay, this is not doing well. There we go. All right, so that's just going to build. And hopefully while it's building, we're going to be having a good time. Just gonna go.
Speaking of good times, for most.
Someone has here the microphone.
1, 2, 3. Okay. Minus J4 is usually pretty okay on laptops, and it'll take you on my M2 5 minutes or 3 to 5 minutes. On
Yeah.
older things, it might be 10, 20 minutes.
This might be a problem for people doing the tutorial right now. If it's going to take them 20 minutes to compile it on their laptop. But there's really no way around that unless we give them all, accounts on the cluster really fast, which isn't going to happen. Hooray, we now have ESC Recon. That's great. All right. So now back here. This is going really slow. So remember what I was saying, you have this source directory, you have algorithms, and eventually we want a reconstruction algorithm that lives under RICO. And then we have factories. We also have a RICO under factories, and then we have this global. You might be like, well, what's global compared to factories? And the answer is that global is where the plugins live that don't belong to detector. And so the actual plugin that we care about is this one right here, RICO under global. This is the other place that's going to be super important. But we're just going to go and create a factory in RICO. We're going to call it H. I'm not going to bother with creating a CC file because we don't need it. In principle, it'll work just fine, but all right, so now we have a reconstructed electrons. Wow. All right, so my whole machine is freezing up on me.
Were you too too bold with the J20? Too bold with the J20?
That's running on the farm. That's not running on my local machine. So this is, I think, is just my machine dying. That sucks.
Do you want to just reboot and log back in?
I might have to do that actually. Sorry guys. I will see you in a second. Don't mind me.
We'll take a 5-minute break. Take a 5-minute break. No, I think it's just, part of the dying is that it doesn't pick up on the note. You should have to repeat this.
Voice subtraction. There's voice.
Yeah, and I'm guessing
voice.
it's one of the things that are, it's just not working. You know, we could have said something earlier. We could have had a 15-minute break.
You should do it opportunistically, that's free.
If you look at my short tutorial from let's say the way to do things, this is a chef, and you actually just use a shell script, let's say, yes, and you come, and we'll set up like how many, it will run with CNET for you with the correct flags, it will set up how many threads to use for the compilation, and it will modify the library path so that the installation directory gets picked up correctly. All of that.
Can you put a link to that in the notes? Because I was having trouble with this to make, sure. So maybe other people might add some basic flash script to the directory. So, for example, this run data stage for people who use that and do everything. Because I done it myself for my branch.
There's a lot of this stuff is in the HDF. That's exactly what it's for. This is what Chris Bilks wrote for himself, so that he could avoid all of this.
Yes, but maybe this thing would work. Main branch.
My tutorial is still like on the start side, right? Yeah.
Yeah, I got the. You do the, yes.
I take it down when I look.
When you will.
Yeah.
I mean, I guess you could do some variations of
No,
the
it's
first
not
tutorial for the setting up stuff. Probably
Because,
the tutorial is working. Great. They're all great. Whatever they're doing.
Yeah, I'm going to
Somebody does
essentially,
tutorials, you just hear.
yeah,
And it's how many days again? It's,
3 days with 1 hour each, so I need
I
to.
think that's enough material, actually.
It's
probably
like
too
too
much,
much.
but you could just see how far you can.
Yeah.
And I think, yeah, so you wouldn't get to any geometry.
I do like being able to, well, I'm gonna see between essentially like this like the last 10 minutes of this that we've been doing, like how to install something. Definitely not what we're doing right here in general.
Right.
Factories.
Oh, but seeing like how much they posted.
Yeah.
Yeah, so like what we did today where everybody came in first was kind of give us a show. I think you did the same kind of video like for the, you know, have them watch some of the AG for training through that material, certain material. That way when you come in and just like really good.
Yeah, I'm gonna cannibalize. If I need to, I will cannibalize what exists. Otherwise, I will probably really just use the material that's exists
Yeah,
here.
I think you can use it. You might have to just skip some sections or.
Yeah.
And it's nice too, because at least you know. I think at least for the first two, those two. I think both create. Pretty good.
Give me just 1 minute just so that we can break through.
Hey, everyone, I'm back.
Okay. People are trickling in. Give it another 2 minutes.
Oh, no hurry. They can take their break. Sorry about that.
Let me test something. 1, 2, 3. Yeah, good. The echo is gone. Is that an issue? Yeah, because I mean, yes, sure, but that's what somebody else was doing. If you file an issue and then do it, so much better. I mean, file the issue as like a feature request or something. Generate how much you tag and then if somebody speaks against strongly and don't, or use yourself. And
At the first time when you consume the geometry, you consume about
It's just an arbitrary.
This is the default actually.
This is what this thing does. All of this code
is what
get larger.
it generates. It just shows you what it does.
Larger.
Okay.
It'll, and this prefix will automatically be in the library path.
Okay.
And at the front of it, so it gets picked up before like the default installation.
I see, okay.
Especially for the library.
But the nice thing is like, okay, if you just want to do something by hand, then you can copy paste from the output of the build and make small stuff. Because I mean, it does that scenic step every time you build. So instead, I just run the I might go build directory if I want to. And we may just do the make and fly thing and we need to work just for these 100.
So we try to.
I'm still build make instead of scenic minus build minus build.
I have to, there's.
Yes.
Oh, back down.
Yep.
Using the more library.
All right, how's everybody feeling? Should we continue?
Okay, I think we're ready when you are, but take your time. You still have a lot to organize, as I can see.
All right, so you can hear me just fine?
Yep, we
All
can
right,
see
I'm
your
just
screen
gonna
too.
Go right ahead. Oh, I'm not sharing the screen. Yeah, you're right. Oh, you can see the screen. Screen's good?
We can see you well. Yep.
All right. So,
Just go to the website real quick. Yep, the code, the size is still good.
great. So last point we left off, there was this, I said, hey, we're just going to copy this electron reconstruction factory code skeleton into EIC Recon, putting it in the place that makes sense. And I just did that. So this lives under, factories, Reco, reconstructed electrons factory. And then the next part of the exercise is just give it a single output collection. And we're just going to do that here by uncommenting this pod.io output. Our output type is EDM for EIC reconstructed particle. We're not even going to give it a name, but that's all we have to do. Then we want to make sure the process method produces some output. I'm just going to add reconstructed electrons factory event, whatever, calling process. All right. So we have some log output. And then in theory, we could give it different input collections. So I'm going to leave that commented out for now, but that's there. So let's move on to the next fun part, calling a factory. We've created this factory. You'll notice it's just a header file. You'll notice that, CMake doesn't particularly know anything about it. You'll notice that there isn't even a CMake lists under the Reco directory of factories. And then the global CMake lists, it's not doing anything with factories here either. So this is really just a place where you stick header files. And that's because there's ultimately not a lot of logic that lives on the factories, and you only need it in a couple of places. So it really makes sense to leave it as a header. And this brings us to the next part, which is we just have this free floating factory somewhere. How do we tie that into a plugin? The answer is this thing called JOmniFactory Generator T. And what JOmniFactory Generator T is it's something that will produce the factories that we need according to, what Jana thinks we need. And basically, if you say we're going to run this with 8 threads, then Jana will go ahead and create 16 factories or whatever. And these factories are tied to individual event objects, which means that even though, yeah, it means that it's really like a local thing. And that means that we don't have to have thread safety, means we can cache local state on the factories. This is great for not having to go down to a calibration database all the time, not having to reload geometries all the time. And you don't have to have any mutexes here because the factory will only call other factories which all live in the context of an event, which is being processed by exactly one thread. So it all lives on one thread in practice. But then there's another, it isn't just that we have multiple copies of the same factory, it's also that we want to reuse that factory logic in a different context. So we might want to have a clustering factory for one detector and then have another clustering factory which uses the same class for a different detector, but you want to change the collection names and you want to change the parameters. And then this is what happens at the factory generator level. And so this is the archetypical, instance of a factory generator. You notice that this is not for the reconstructed electrons factory. This is for MC2 smeared particle factory. Why that one? Just because I picked it out of a hat. Because I wanted you guys to have a little bit of work to do in your exercises of actually changing things. But the way that you interpret this is that you're creating this generator object. It's templatized so that you're passing in the type information of the actual factory that you need as a template argument. You're giving it a unique tag. And this tag says, this is our Omni factory for just generated particles. So this is a really basic tag. If there isn't something special about this one, so one good tag would be like, oh, these are generated particles for whatever. But if it's just generic, if there's only really one of them, then you can give it the name, which is the same as the output collection. And then pod.io output collections need to be unique, so it all works out. So you have the tag, and then you have the input names, and these are names for all of your input collections, and you have names for all of your output collections. And then we're passing this app back to the Omni factory generator, which is really just a quirk of how it was set up, and sneak preview on the next release that might be going away. You might not need to pass the app anymore, but for now you do. So we're done with factories for now. And now we want to go into our global Rico plugin, rico.cc. And we're going to just add, so this is the init plugin for the rico.cc. As you can see, we have a lot of different Omni factory generators, and they're pulling in a lot of different factories. And as you can see, some of them come from factories, others come from global Rico. I think the idea was
plugins are in global. Plugins are in global directory.
yes.
Right? Okay.
Yes. So the detector specific plugins are under detectors, but the things that you should be applying to multiple detectors or just in general, all of that goes under global. And electron reconstruction is obviously reconstruction, it's in the name. So rico.cc is the place we put it. Right, so we can go just to the very bottom of all of this, and we can just paste in our.
Sorry, can I ask you, on lines 172 and 80, there is already reconstructed electrons factory.
Line 172.
Because he essentially just copy pasted this as an example.
Okay.
You are supposed to change this.
Okay.
And do your own electron identifier using.
That's a good point. Yeah, I should give this a different name actually. So
exactly. This is what I'm talking. Yeah.
Yeah. And this is because we created this tutorial while we were developing this reconstructed electrons factory, but then we went and used the actual name for the real one. The tutorial is just a little bit too realistic.
Just call it toy or something like that.
Exactly.
Oh, did you hear that?
Yeah, we can leave the mic open here.
Oh, if it falls down, that's gonna
Break the iron. Yes.
Toy reconstructed electrons underscore factory. And we're just going to name this one reconstructed electrons. Change that to reconstructed electrons, and then we don't have any inputs, so we leave that empty. Ta-da! Oh, and then we have to go to the top. We have to add the header file. Doesn't actually exist because I have to go back and rename it. Toy reconstructed electrons factory.h. Go back in here. Name that. Okay. So that's all pretty good. See what happens when we go ahead and compile that.
Sorry, I missed that. What have you put inside the body of the reconstructed factory? Not here, not on in the plugin section.
Yeah, so we go back to the plugin. We'll reco.cc.
In the very end.
Yeah.
Okay. On the output. Okay, thanks.
That is leave that on the screen for a second. Okay. How's it going with the wiring up the OmniFactory generator?
And what command have you used to recompile? You build again and install again?
Yeah.
And removed build and install folders first? Or
You don't have to remove it.
yeah, okay, yeah, I know. Okay, thanks.
I mean, I hope you don't have to remove it because that'll take forever for all of us. I have to find an output file, unfortunately. There we go. Oh, no, oops. How is everybody doing? I'm going to discover in a moment that the whole call dropped. I didn't even notice. Seriously, where is everybody?
And what are the other steps after the compiling?
All right. What a great question. All right. So sorry, I don't have this nicely set up for you. But basically what you have to do is you have to go and set up your detector. And so you do that by just sourcing this shell script right here. It's under /op/detector/setup.sh. And then you need to run EIC recon on an input file. And I'm guessing that people don't have an input file just floating around. So I'm going to get you a link to one on GitHub really fast. I'll show all checks, show details, show summary. Show me my summary, please. Go all the way down to artifacts. Sim E. I think this is the one that we want.
And will it work with our Epic version and EIC recon version?
Yeah, so that's why I'm pulling a recent one because they get out of date at some point. So I'm just gonna copy the download link and paste it in the chat, and hopefully you guys can either take it from the chat or I think I should do that on Mattermost, shouldn't I? Mattermost. That one. That. Do. It's gonna paste it in the chat right here. Once I find the chat. So otherwise you can just go to a very recent pull request and then find the sim file that's there and just pull it. All right, so you need to set up your detector and then you need to obtain the file. And then once you
Can
have the
post
file,
it on the, sorry, can you post it on Mattermost?
yeah, just give me a moment. Um, uh, so Keith, you have your hand raised.
Yeah, I was just gonna say, I mean, I think if you don't set the Jana plugin path, then it picks up the .so files from the default EIC recon install instead of your local install there.
It shouldn't, but it's by all means set the Jana plugin path to be the install directory because that is a much more reliable way of doing it. It should show you exactly what plugins are loaded when you
Yeah, like when you ran your EIC recon, I think it showed user local lib, which I think
did
is
it. We shall. Look at that, you're right. All right, so we'll also set the Jana plugin path to point to the other one. It's a good catch. It saved me a moment of disappointment in the near future.
Oh, can anyone from the Zoom post the link on the Mattermost, please?
I was working on that and then got distracted.
Thanks, it's already there. Thanks.
Oh, somebody posted it. Perfect. Are you guys seeing the orange screen or the you know, or are you seeing the code right now?
We're seeing your Mattermost in the foreground,
Ah, that was not what I wanted to show.
and now your shell.
And now my shell. You know, I'm great at technology. All right, so we're going to set our Jana plugin path. Did we all get that? And now hopefully we can run EIC recon and we get the thing we expect. Now note that I'm also passing this -p Jana : n events equals 3. That's another useful parameter which says don't give me all 1,000 events in the input file.
Yeah, it needs to point to the install EIC recon / plugins, like the whole path. So you have export
Oh
Jana.
yeah, you're right. You're right. Lib /
Sorry, why not the source ERC recon first?
why not what?
Why not the source simply ERC recon? in the install directory, there is a source file.
Well, that might
And
work.
that would put all of the variables.
Yeah. Ah, God dang it. All right, so if we source that and run this thing.
And you don't need install pin and so on.
Yeah,
No.
that setup script doesn't really work well. The long run.
Yeah, I haven't used it. Like I knew it was there, but
Yeah,
I've never.
the easiest way to do it is just to set the Jana plugin path directly to the libic recon plugins directory, and then you should be fine.
Okay.
Yay, that's better.
Can you post on Mattermost or in chat Zoom the variable you set on Jana?
Yeah, absolutely.
So it's equal to empty, sorry, on
No,
your
no.
Mattermost, because it's all empty.
Yeah, but that's
Can you please post the whole string?
um use install / live / guys recon / plugins. And the PWD is supposed to be in backticks. So you know what? I forgot to do. We need to have our toy reconstructed electrons match up so that we're not conflicting with our real reconstructed electrons. Skip the grep part. How's everyone doing?
There was error for grep file for me. So there was no theory construction.
Sorry, what was there you're getting?
I couldn't find the matching sequence theoretic.
Do you want to share your screen? You just need to ask. Could you stop sharing for a second so then he can
Yeah,
share?
sure.
Yep.
Yeah, skip the grep part for now.
Okay, where do I go? Here. So this is output of my,
Yeah,
and I want to find this rec, theoretic.
yeah.
Do I go somewhere? I'm following your instructions.
All right, so
I have an output as a file, so I can go
yeah.
type in and no grep. Toy. And there's an error.
Yeah, that just means that it didn't find it.
Yeah, exactly. So it means there's some mistake and okay.
Holly, from a strategic perspective, we have like half an hour left. Does it make more sense to keep debugging or does it make more sense to go through with the lecture?
Probably Holly had to take a phone call. Probably better to continue with the lecture. After that, whoever wants to hang around, if you want to hang around, maybe we can follow up. But I also don't want to put that on you. It's long enough as it stands. But let's finish the lecture first.
I was thinking that because, like I said, we have half an hour, and at some point we're gonna get bogged down in doing this, and some amount of this is just friction with EIC Recon itself. So I do want to share some factoids with you so that you can get back to it later. All right, so which screen are you seeing? Are you seeing the Mattermost or an empty screen?
Right now,
We are seeing your friendly face, so you need to start sharing again.
You are Great. Yeah, no, I'm so sorry. We want now. There we go. How is that?
Yeah, seeing your browser.
All right. So we're going to get back to where we were. We've added the Omni factory generator. We've put the generator where it belongs. And now the big question is, how do we make sure that the factory actually gets called? And this is a good time to talk about factories in Jana. So in Jana, factories can request collections. Those collections are provided by other factories. Under the hood, you don't have some kind, so like a reconstruction framework like Gaudi would do a topological sort and then say, I need to run these algorithms, so this is the order that they can run in, and then I'll just run them in this order. It's not how Jana works. So what Jana does is it says, hey, I need this output. And then the factory that produces that output says, hey, I need these inputs. And then the factory that provides that input says, okay, I'll run, but I need these inputs. And so it works backwards as opposed to forwards. And the reason this is nice is because this means that outputs that are not used by anything never get run. And so you get exactly what you ask for and you don't get extra, unless that extra thing was necessary to produce your outputs. But it doesn't just run everything it can possibly run. However, this also means that if you just add a factory and you add a generator, Jana will know about your factory, but it won't be at all inclined to run it. And the way that we tell Jana to run the factory is by asking for the factory's output as something to put into your output file. And you can do this on the command line very easily by just saying, by overriding this pod.io output include collections parameter. And so whatever collections you want to be put into your file, you just say, please include these, and it will include those. Now, obviously, you don't want to be doing this all the time. What you really want is somebody to say, these are the factories that we want, the outputs that we want for reconstruction in the general scheme of things. And then we will obtain those every time we run EIC recon. And so we have this variable called output include collections, and it lives in this file right here, jeventprocessor pod.io.cc. And the way that you make sure your factory always gets run is by adding your collection name to this long list of output includes collections. And if you're familiar with the Jana parameter manager, you might think, wait a second, this pod.io output includes collection variable is being overridden by this parameter that I'm specifying here. And so that makes a lot of sense. Now, it's not always the case that this is how you want to do it, though, particularly for intermediate results. Like one thing that you might want is another factory that calls this factory. And so there's a way that you can do that as well. So imagine that you have a factory which has a tag that's just target factory. And then you want to say, hey, instead of using the collection names that you were told to use by your Omni factory generator, we just want to go and override that and use these particular collections instead. You can pass it the name of the collection that the factory you just created produced. And then just for this one time you run it, it will use that. As you can see, this gives you a lot of power to rejigger how things are run on the command line. But in this case, you're just telling the factory, hey, use my new factory instead of whatever you're using before, and they'll do it. And then obviously, if you want to permanently use your factory's outputs as inputs to another factory, you go into the Omni factory generator for that part, for that factory, and say, we're going to pull in
the collection name from our new factory. And then you're sort of saying, you know, this is my output is being consumed by this other factory, and that means I'm going to be called. And so the whole point for this exercise is to go ahead and